We're going to review solving systems of equations and inequalities today. Solving systems of equations and inequalities is something you've done several times in prior classes, but we're still going to review it here. There's substitution, there's graphing, and then there's elimination. Depending upon the directions or the type of question will depend upon the method that you're using. So if we review this solving substitution, since they both equal to y, we could take one of them and plug it into the other since they both equal y. So we could take our x squared right here and plug it in down here. We get x squared is equal to 2x plus 3, and that's what we have here. At this point, it's just a nice normal quadratic, so you set it equal to 0, and then you can factor it. After you factor it into an x minus 3 and an x plus 1, equaling 0, you set each factor equal to 0, you get negative 1, and you get 3. So then you need to take negative 1, plug it in so that you can find your y value. I'm choosing to plug it into the top one. It would still work and give you the exact same answer even if you plugged it into the bottom one. It would not make a difference. Take our negative 1, plug it in here, get negative 1 squared, we get 1. So we plugged in negative 1 and we got out positive 1. Down below, we'll take our other value of x, plug it into our x squared, and we end up getting 9. So then we had the point plugging in 3, getting out 9. And so we get the point 3 comma 9. So we have two answers. Your answers when you're dealing with systems of equations will always be points. Remember, points are listed as ordered pairs or ordered triples if you're dealing with 3 variables, but they have to be separated by commas and in parentheses to indicate that they're a point. So we started out with a parabola and we started out with a line. Here's your parabola, here's your line, and they cross at 2 points, the negative 1 comma 1 and the 3 comma 9. Would a line and a parabola have to cross each other? No. Or if they did cross, would it have to be twice? So it could be 1, but a lot of times it's going to be 2 points. But once again, they are points, so write your answers as coordinates of points. Substitution, you typically want to solve one of your equations for y or x, and then plug it into the other. So here we have a circle and we have a parabola. We would know the top one's a circle centered at the origin with a radius of 5. If we get this in our standard form for a parabola, we'd have to subtract our x squared from both sides. You know it would be a parabola opening downwards with a vertex of 0, 19. To solve this system, we could solve the bottom one for y, but then if we plugged it in, we'd have to then have something with a 19 and an x squared, and then we'd have to square that. Since they both have x squareds, it's going to be easiest to solve it for x squared. So subtract 19 from both sides. Then all we have to do is to take this, which is an x squared, and plug it in right here. When we do that, we get this. Well, now it's just a nice, normal, simple quadratic. So to solve a quadratic, you know you want to have it set equal to 0. Then you could easily factor this, or if it didn't factor, you'd use the quadratic formula. Set each factor equal to 0. Solve it, and we get y to be 3. We get y to be negative 2. Now, those are the y values. You still have to figure out what x is. Now, whether you take this y of 3 and plug it in up here, or take the y of 3, plug it in here, either one you can go ahead and solve for x. If you plugged it in 3 here, you get x squared plus 9 is equal to 25. Subtract your 9 from both sides, you get x squared to be equal to 16, and so you get plus or minus 4. So you get 4 when you plugged in 3, and you also got negative 4 when you plugged in a y value of 3. Then you'd want to take your y value of negative 2 and plug it in. And once again, you could plug it into either one of these. If you plugged it into the bottom one here, you'd have to add 2 to both sides, and you get x squared is equal to 21. Then you solve that, you get x to be plus or minus 21. So positive root 21 when you plugged in negative 2, and negative root 21 when you plugged in 2. We could have plugged it into the top equation. We would have still got the same answers. So we have 4 answers here. We have our parabola and our circle crossing at 4 points. And you can see that over here on our graph. Now, we can use elimination at times. Substitution will often work and often works nice. But with elimination, you want to get one of your variables to have opposites in front. So you could do that by going ahead and multiplying the second equation by negative 3. So bring the first equation down, multiply the second one by negative 3. So if we bring the first one down, multiply the second one by negative 3, remember to multiply everything on both sides. Then you're going to add your x's. When you add your y's, they drop out. Add the normal numbers. Now it's a fairly simple equation. We get x by itself, we get 2. Then we could plug x being 2 into either one of the original problems to be able to find y. It would not make a difference which one you choose. I'm choosing the second one. Oh, sorry, the first one. So x being 2, then plus 3y equals negative 1. Subtract 2 from both sides, divide, and we get negative 1. So we would have the point 2 comma negative 1. So we know our 2 lines cross at that point. If you go ahead and graph the 2 lines that you were given over here, you can get a nice visual, and you can see that yes, they do cross at 2 units over, 1 unit down. Now, 2 lines don't have to cross at one point. It is possible the 2 lines that you have will be one on top of the other and have infinitely many solutions. That happens if one equation is a multiple of the other equation. If you multiply the second equation here by 1/2, it gives you the first equation. So in other words, everything's identical. So if you did go ahead and try to solve this by elimination, if you got opposites, you could multiply everything here by negative 1. If you added everything together, everything would drop out and you get 0 equals 0, which is a true statement. So if you get a true statement with no variables, it's infinitely many solutions, which they're the same line. This one here, if you go ahead and multiply this first equation by negative 2, you get a negative 6x minus 2y is equal to negative 12. Bring over the bottom equation. Then if you add these together, everything on the left drops out, but on the right, not everything drops out, and we get 8. So here we're left with no variables, and we know that 0 does not equal 8, so this is a false statement. So if everything drops out and you get a false statement, then they end up being parallel lines. Their slopes are going to be the same, but because these numbers on the right-hand side are going to be different, the y-intercepts end up being different. So if you get parallel lines, you have no solution. So you could have, with 2 lines crossing, one solution. That would mean the slopes would have to be different and they cross at one point. That's considered to be consistent and also independent. If the 2 lines are the same, so you'd have to have the same slope and the same y-intercept, then the systems are considered to be dependent and consistent, which means they have infinitely many solutions. If the 2 lines are parallel, meaning they have the same slope but different y-intercepts, then they don't cross, they have no solution, they're considered to be inconsistent. Now, you don't necessarily just have to have lines. You could be dealing with other curves. And we don't have to be dealing with just equations. We could be dealing with inequalities, which means we're going to be shading either on one side of the curve or the other side of the curve. When we look at y squared is less than x plus 4, we could always graph this by making ourselves a t-chart. Normally, we have y on one side by itself equaling something with the x, and then you plug in stuff for x to be able to figure out y. Since it's hard to get y on one side by itself here, I would go ahead and make my t-chart where I plug stuff in for y and work backwards to get x. When you do that, you would get a parabola that's going sideways. Now, sometimes you're going to have a dotted edge, and sometimes you have a solid edge. You have a dotted edge if it's a less than or if it's a greater than. You have a solid edge if it's a less than or equal to or greater than or equal to. So if you have the equal to with the extra line, then it's a solid curve on the outside. Then you have to decide, do I shade on the inside part of the curve or the outside part of the curve? What I would do is I would choose a point that's not on the edge of my curve. For this particular problem, I'm going to choose the point 0, 0. If I plug in x being 0, plug in y being 0, I would get 0 on the left-hand side. I would get 4 on the right-hand side. And we're dealing with a less than. And 0 is less than 4. That's a true statement. So I try to point here. It works. So that means I'm going to shade on that part of my graph where that point is. If I had chose a point and plugged it in and it did not work, I would have had a false statement. So I would not shade where my point was. I would shade on the other part. If you're dealing with a line cuts your xy coordinate system in half. If it's a linear inequality, meaning a line with an inequality, then you're either going to be shading above or below. So a linear inequality is really half your coordinate plane. Half of it works for you, and then half of it doesn't. So if you are graphing a system of inequalities, your system of inequalities is and your answer to that system of inequalities is the one region where both shaded regions work. If you're looking at this pink line here, you're shading above that pink line. If you're looking at the blue line, you'd be shading below the blue line. Your answer is where they both work, and that's the purple here. So you would not have any shading left here, you would not have any shading left here, you'd only have your final answer would be the shading where the purple is. So just know that your answer for inequalities is where all the shading regions overlap. So consider this inequality system here. We have y is greater than or equal to 0. Well, y is equal to 0 is your x-axis. Greater than or equal to, so we know it's going to be solid here. Greater than or equal to, we're going to be shading above. So we're above the x-axis. Y is greater, or x is greater than or equal to 0. X equals 0 is your y-axis. X is greater than or equal to means we're going to be shading to the right of the y-axis. When we are looking at the blue one here, we could go ahead and get y by itself. And you could see that this is in the form of y equals mx plus b, so our y-intercept would be 4, our slope would be -1, so you can see that we would get this here. Since you have y less than or equal to, we know it's solid, but less than, we're going to be shading below the blue. If we are looking at the pink, looking at the pink one here, we get y by itself. Remember, when you multiply or divide by a negative to switch your inequality sign, we get a y-intercept -4, a slope of 2, so up 2 over 1, up 2 over 1, up 2 over 1, and so on. It's solid because of the equal to. Y is greater than, so that means you're going to be shading above the pink line. So when you graph all these and only look at where they're overlapping, that's just the shaded purple region here. So that would be your answer to your system of inequalities. Down below here, we have a circle and we have a line. This circle would be centered at the origin with a radius of 4. It would be a solid curve because of the equal to. So we have a circle radius 4. It's less than, so that means you're shading inside the circle. When we look at this one here, just a second, we could get y on one side by itself by subtracting an x. So then we'd have a slope of -1 and a y-intercept of 2. We know it's solid because of the greater than or equal to. Its y is greater than, so that means we're shading above the line, but the top one we're shading inside the circle, so therefore it's only this shape right here.